Hello. Um, I'm going to start section 3.5, which is called absolute extrema. And so it's a little bit easier than local max and local min. This is absolute max and absolute min. So I'm going to show you on the paper what I'm talking about and how to, and then I'll work the problems and show you what's going on. So as always, send me emails if you have questions, and I don't have any scheduled Zoom office hours. I can, but until you watch the videos and get started, and then you can tell me what your questions are, then we can decide. We're just going to play it by ear and be very fluid. Okay, so use your voice, speak up if you need to, but here we go. All right, absolute extrema on a closed interval. Let's talk about what we've already done. So here's what, let me get my friend, the dot cam over here. Okay, so in 3.4a and b, we talked about graphs. Okay, and so to recap, if you look at this graph, it goes, there's no absolute minimum because it keeps going down forever, and there's no absolute maximum because it keeps going up forever, okay? But we did talk about these points right here where we had the slope was 0, the horizontal tangents where the derivative was 0, and they called them horizontal tangents or an A, and they call them critical values in B. And then B, they called them critical values. And for us, it's where the derivative is 0. Okay, so we see that. And then, so we had these, this was, if this is A, we had a local max at X is equal to A, because it went to the top and it went to the bottom. We made our sign chart, and this would have been our local minimum at X is equal to, let's call that B. Okay, all right, so what we're going to do with the absolute extrema, we're going to have to look at this a little differently. We're going to have to look at this on a closed interval. So if, so here we go. So in section 3.5, we're going to talk about absolute extrema on a closed interval. So again, if I have my graph, if you look at it, again, it has no absolute max or absolute min. It has local max and local min. But if I, let's say, let me think for a second. So minimum is there, maximum is there. So let's say we look at this graph just from on a closed interval from A to B. So we're not dealing with all this. And so if we close off the graph, it's what's the highest place on the graph? Well, actually there are two. They're right there. And what's the lowest place on the graph? Okay, that is the lowest place on the graph. So you have the absolute maximum, you have two of them that occur at X is equal to A and X is equal to B. You just happen to have two. And there was the absolute minimum. Let's call this C. Okay, and that was at our local min was the absolute min. Okay, all right, so now we can have absolute max, absolute min on a closed interval. If you're given a closed interval right here from A to B, an absolute max, absolute min will exist. Okay, all right, so I'm sure he put all that in the lecture video. So what we're going to do is these are the steps to find absolute max min. Okay, the first thing we're going to do is find the critical values. And remember, this is on a closed interval, A, B. Okay, all right, so find your critical values. So you set f prime of x equal to 0 and solve for x. So an absolute max or min can occur at a critical value or at an endpoint. So what we're going to do, too, is we're going to plug my critical value into my original, and then we're going to plug my endpoints A and my endpoints B into my original function. Okay, so A and B are the endpoints. Okay, and then I'll look at the numbers. I'm going to get numbers out. Okay, I'm going to look at these. And then the largest number is the absolute maximum value, and the smallest number is the absolute minimum value. And then the smallest number, because we're looking at these outcomes after we plug the critical values and the endpoints into the original function. Okay. And the smallest number is the absolute min value. Okay, so let's do it. Ready? Ready. All right, so there are like 6 of these questions on the homework. Okay, and I'll just show you the examples. So it says, consider this function on the interval from 0 to 4. Find the absolute extrema, meaning the absolute max, the absolute min. All right, so I'm going to just write this down. It's easier to see. So f of x on the interval 0 to 4. Okay, so that's my A and my B. So it'd be nice if you could see that. Okay, so I have a function on an interval, 0 and 4, that's my A and my B. Okay, and so let's look at my steps. The first thing we have to do is find the critical values, take the derivative, set it equal to 0. Then we're going to plug our critical values and our endpoints into f, the original function. Okay, all right, so let's do it. Find your derivative, set it equal to 0. So 10x is equal to 30. So x is equal to 3. This is my critical value. Okay, so I'm going to plug x is equal to 3, x is equal to 0, and x is equal to 4 into the original function f of x. Okay, this is my critical value, and these are my endpoints. All right, so what is my original function? 5x squared minus 30x. Okay, so I'm going to find f of 3, f of 0, and f of 4. Okay, I'm going to go let my dog out. I'll be right back. Okay, so here you go. Okay, all right, did y'all do that yet? So if we're plugging in all these numbers into one function, I would probably use my, use your store. I might use my table function, okay? And so I am going to clear out the table, and I'm plugging everything into 5x squared minus 30x. So 5, there's your x squared minus 30x. Okay, and then yours might be on auto. I would just go to ask, so you could just plug in 3, 0, and 4 instead of scrolling up and down. If I had it on ask, I would have to just scroll until I found 3. Oh, there's 3 up there. You see what I mean? So I'm going to go, whoops, to my table, and I'm going to arrow over to the ask and push enter. So it's clear. I delete whatever's there, and so I can just ask. So I'm going to put 3 in, and I get -45. I'm going to put 0 in, and I get 0. And remember, I'm putting it into my original function. I'm going to do 4 and push enter, and I get -40. All right, so I've got my values out. So remember, what this says is once I find f of my critical number and f of my endpoints, I get all these numbers out right here. Okay, and so I look for the largest outcome and the smallest outcome. So -45 is the smallest outcome. So that means I have an absolute minimum at the point 3, -45. So there's your x and there's your y. Sometimes they'll just ask for the x value. So I have an absolute minimum when x is 3, and the minimum value is -45. So when I plug in 3, my graph jumps down to 45. And then I have 0 and I have -40. So the largest outcome is 0. So that's my absolute maximum. My x is 0. What I plug in, this is always your x, and this is your y. Okay, so I plug in 0 and I get 0. So I have an absolute maximum when x is equal to 0, and the absolute maximum value is 0. And that's how you do those. And so we're just going to do that to the next few problems. So example 2. Y'all hear the roosters? I don't know if you can hear the roosters in the background, but I live in town. Like, I'm not out in the country on the farm. I'm in town. But anyway, all right, so here's my function. F of x is 2x cubed plus 6x squared minus 18x. And they give me the closed interval, -4, 6. Okay, and they want me to find the absolute maximum and the absolute minimum. And the absolute maximum is a point with an x and a y term, and the absolute minimum point has an x and a y term. Sometimes they just ask for the x. You have to watch what they ask for. Okay, all right, so the first thing we do is we take our derivative, 6x squared plus 12x minus 18, and I set it equal to 0. And I have to factor, but remember, we know it's easier to factor when you can have the coefficient of x squared is 1. And so let's take a 6 out of everything, and I'm left with x squared plus 2x minus 3. Factor out a positive, the signs remain the same. You divide each term by 6 to see what you have left over. And then I factor x squared is x times x, and 3 is 3 times 1. So I know those are right. But the only way I can combine 1x and 3x to get +2 is to have +3 and -1. Okay, so 6 is just a factored number. There's no x there. So I set x plus 3 equal to 0. So x is -3. X minus 1 is 0, and x is 1. So these are my critical values. Okay, and so I have to plug into my original function. I have to plug in my critical values, f of -3 and f of 1. And remember, you can also have absolute maximums at your endpoint. So this is my A and this is my B. You have to check your endpoints, okay? So F of -4 and F of 6, and I'm getting those numbers from up here because the absolute maximum occurs either at critical values or at your endpoints, okay? So these are my critical values. And then F of -4 and F of 6. And these are my endpoints. All right, so let's move this up so you can see. All right, so again, I'm going to take my calculator and I'm going to put it in my table since I've got all these. All right, so I go to my table. I've got something there, so I delete it. And so I put in my original function, okay, 2x cubed plus 6x squared, 2x to the third, and then you have to come down, plus 6x squared minus 18x. Okay, and I just push enter, enter, enter. Once you put it on ask, you don't have to do it again. I like to clean up my table, so I delete. Don't clear it, it clears your function out. So delete, delete. So now I have a clear table. Okay, so I'm going to put in my numbers that I need to evaluate. So I have to check, make sure 2x cubed plus 6x squared minus 18x. Okay, I'm just a little OCD. So I'm going to plug in -3, enter, and I get 54. Okay, I'm going to plug in 1, enter, and I get -10. I'm going to plug in -4, enter, and I get 40. And I plug in 6 and I enter and I get 540. So I hope you see how I use my table. When I went to table, I just plugged in my original function. Okay, and this is my X. Okay, all right, so I'm gonna quit. All right, so now here I go. All the hard work is done and I look here. And so what is the largest value there is 540. So I have the absolute maximum point at 6,540. So remember, here's your X and here's your Y part of the point. So I have an absolute maximum when X is 6. The absolute maximum value is 540. Okay, and then let's go look at the smallest value. There it is, -10. So I have an absolute minimum point at 1, -10. So here's your X and here's your Y. Here's your X and here's your Y. Remember, this is your X and this is your Y. You plug in 1 and you get out -10. So I have my absolute maximum point and my absolute minimum point. Now, sometimes they just say find the X value of the absolute min would be 1. The X value of the absolute max would be 6. So you have to watch whatever they ask for. Okay. All right. So let's move on to the next problem. One, two. Okay. Got them out of order, but that was number 3. This is number 2, but it doesn't matter. So f of x is x cubed minus 12x on the interval from -7 to +5. Okay, and they want the absolute max and absolute min. Okay, so here we go. All right, so I find my derivative. F prime of x is 3x squared minus 12 is equal to 0. Okay, so I have to factor that. So I want the coefficient of x squared to be 1. So if I take out a 3, I get x squared minus 4, and I set that equal to 0. Okay, so I can throw out the 3 because it doesn't have an x there, but remember, x squared minus 4, you lost your middle term. So this is just a difference of squares. X plus 2, x minus 2 is equal to 0. Because remember, I'm solving a quadratic equation. So that means I'm going to get two answers. I'm going to show you a common error. But when I set x plus 2 equal to 0, x is negative 2, x minus 2 is equal to 0, and x is equal to 2. So let me just show you something real quick that people do a lot here when they're solving 3x squared minus 12. Some people, because there's no middle term, try to isolate the x, and they divide both sides by 3, and I get x squared is equal to 4, and people go x is equal to 2. But the square root property from algebra says x is equal to plus or minus the square root of 4. So x is plus or minus 2. So be careful not to just call x is equal to 2. You'll probably miss the problem. That's why I like to use the factor method, because you see that there are two factors and you get all your. So these are my critical values. And these are my endpoints, A and B. Okay, so I'm going to plug everything into my original function. And I'm going to do f of my critical values, f of negative 2, f of 2. So these are my critical values going in. And then f of negative 7 and f of 5. And these are my A and my B, my endpoints. Okay, so I got a lot of stuff to plug in. And y'all, this is where people make mistakes, because they don't use their calculator. I use my calculator all the time. You know I do. So I'm going to get my calculator. And since I've got so many things to plug in, I'm going to go to my table and then clear it and plug in my original function, x to the third minus 12x, x to the third, and the cursor gets stuck up there at the 3, and it doesn't when you use your squared button, but you got to come down, say minus 12x, and I'm going to enter, enter, enter. I'm going to ask, enter, enter, and I've got all this stuff in my table, so I'm just going to delete and do my arrow, delete, delete. So I just like to have a clean table. So negative 2, enter, gives me 16. 2, enter, gives me negative 16. Negative 7, enter, gives me negative 259. And 5, enter, gives me 65. So remember, I'm looking at all of these outcomes, and I'm looking for the largest number and the smallest number. So I look, and the largest number I get is 65. So I have an absolute maximum point at 5, 65. So remember, these are your x's that go in and your y's that come out. Okay. The smallest number is negative 259. So I have an absolute minimum point at negative 7, negative 259. Okay, and so that's it. And then I believe on the test sometimes they'll say find your x value of the absolute min, which would be x is negative 7. Find the x value of the absolute max, so it would be x equal to 5. So y'all see where I'm getting everything. And if you don't, what are you supposed to do? Email me. That's right. Okay. All right. So let's look at my next problem. So now I have 3, 4, 5, 6. All right. So f of x is 4x cubed plus 66x squared plus 360x on the interval negative 8, 3. And remember, that's your A and that's your B. Oop, you can't even see. Let's write the problem down. F of x is 4x cubed plus 66x squared plus 360x. All right, let's do it. Let's find my critical values. 12x squared plus 132x plus 360 is equal to 0. And I better check my 66 times 2. Oh my goodness, my dog is 132. All right, so 132 divided by 12 is 11. Okay, so if I factor out a 12, I get x squared plus 11x, and 360 divided by 12 is 30. Okay, so here we go. I've got x and x, and I've got numbers that multiply to get 30, but they had to add to get 11. So let's look. 2 times 15, that won't do it. 3 times 10, that won't do it. 4, 5, 6 times 5, there it is. So if I have 6 times 5 is 30, and positive 6 and positive 5 add to get 11. X plus 5, x plus 6. Okay. All right, so 12 I can just not worry about. So I set x plus 5 is 0, x plus 6 is 0. So x is negative 5 and x is negative 6. So these are my critical values. So I'm going to plug everything into my original function. Okay, so I'll plug in my critical values, f of negative 5, f of negative 6, and then these are my critical values, and then I've got to do my endpoints. So f of negative 8 and f of 3. So these are my endpoints. Okay, so again, I'm using my calculator. So I'm plugging, I'm gonna go to my table and clear it out and plug in my original function, 12, what is it? 4x cubed plus 66x squared, 4x to the third, come down, plus 66x squared, and then you don't have to come down from that, plus 360x. Enter, 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 I'm gonna ask. And then I've got a bunch of stuff in there, so I'm gonna delete, so I can have a clean table. Okay, so negative 5, enter, I get negative 650. Negative 6, enter, I get negative 648. All these negative numbers drive me crazy. Negative 8, I get negative 704. And 3, I get 1782. Okay, so I've got to look at these outcomes and look for the largest and the smallest. So clearly, I have an absolute maximum point at 3,1782. Remember, these are your x's and these are your y's when you're making your point. So what's the smallest number? Well, it's the largest number with the negative, right? So this is my absolute minimum point at negative 8, comma, negative 704. Okay, and you just don't worry about everything else that you get. All right. Okay, so the next two problems are word problems, but they're not crazy word problems. They just have more words in them. Okay, we're not going to worry about it. All right, so here we go. Home stretch, last two problems. I'm going to let you do this one first. Okay, number 5. It says the weekly revenue from the sale of X units is given by, and they give you the revenue function where 0 is less than or equal to X is less than or equal to 26. Well, that's the same thing as this, from 0 to 26, okay? And they want to maximize the revenue, okay? All right, so let's write down my revenue function and my interval. We're going to do the same thing. So my revenue function, I just have more room to work here. My revenue function was 180x minus 6x squared from 0 is less than or equal to x is less than or equal to 26, which is the same thing as 0 to 26. And then this one is a little different because they want to say, all right, so how many units should be sold to maximize the revenue? Okay, so they want to know the X value. That's the number of units sold to maximize the revenue. So before we start thinking about my answer, let's go find all the possible ones. So the first thing I have to do is find my critical values. Set it equal to 0. And then 180 is equal to 12x, or I could move my negative 180 over, doesn't matter. And so 180 divided by 12 is 15. So that's my critical value. So I find R at my critical value, and then R at my endpoints, and plug it into my revenue function that they gave me. So nothing different, right? Instead of just saying, here's the function in an interval, they call it a revenue function. And this is what X can be between. X can't be negative because it's the number of units sold. And they're saying X can't be greater than 26. So this is my closed interval they give me. So I'm going to take my numbers and plug it into my revenue function. Okay, so here we go. Clear, I'm going to go to my table and clear that out. I'm going to put in my revenue function, 180x minus 6x squared. Enter, enter, enter. I have it on ask, which is where I want it. I'm going to delete all this stuff here. I'm going to put 15, enter, 1350, 0, enter, and I get 0. 26, enter, and I get 624. Okay, and so they are asking me, let me show you the question. How many units should be sold to maximize the revenue? Okay, so look, if I look at these values, right, this is the largest one. So I have an absolute maximum point at 15, 1350. So this is the maximum revenue when X is equal to 15. So they're asking for your X and not your Y. But you had to look at the Y's to figure out the largest one. And then you said, well, when X is 15, my revenue is maximized. It's up to 1350. And so my answer is X is equal to 15. Okay, so you just have to be careful about reading it and see what they're asking for. All right, and then last one, drum roll, here we go. Okay, let's look at this. A little bit more, but we know how to do this. Okay. All right, so here's my question. The weekly revenue from the production and sale of X units of oil is given by this revenue function. So I'll just write it down. 289x minus 2x squared. And it says the cost function is given by this. So 2x squared plus 217x plus 6 in thousands of dollars. And find the number of units of oil that are to be produced to maximize the profit. Okay. And when they're asking for the number of units, they're asking for X to maximize the profit. Okay, so here we go. That means we have to take the derivative of the profit and find my critical numbers. Okay, well, they didn't give me the profit function, so I have to write it. We can do that because we did that on, what was that, test 2. We know that profit is the revenue minus the cost. And they gave us the revenue and the cost. So it's 289x minus 2x squared minus the cost function, which is 2x squared plus 217x plus 6. And use your parentheses when you subtract, right? So let me make sure I have everything written down correctly. 289x minus 2x squared plus 217x plus 6. Yep. And 0 to 16. Okay, so same thing, but first I have to find my profit function. So I have to distribute my negative and combine like terms. So 289x minus 217x is 289 minus 217, 72x minus 2x squared and minus 2x squared. Okay, so there's my profit function. Okay, and if I'm maximizing the profit, I'm not worried about anything but this right here. This is my profit function. This is where I'm going to find my critical values. This is what I'm going to plug into. They're not asking for maximum revenue or maximum cost. They're asking for the profit function. Okay, all right, so let's find my critical numbers. 72 minus 8x equals 0. X is equal to 72 divided by 8 is 9. Okay, so X is equal to 9. That's my critical value. So I have to plug my critical value into my profit function and my endpoints. So P of 9, and what are my endpoints? P of 0 and P of 16. I gave us those. This is my critical value, and these are my endpoints. All right, so again, I'm going to use my calculator and go to my table function and clear what's there. I'm going to put in my profit function 72x minus 4x squared minus 6. That's right. And I'm going to push enter, 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 enter. I'm going to delete, delete, delete so I can have a clean table. 9, enter, and I get 318. 0, enter, and I get negative 6. 16, enter, and I get 122. Now remember, they're trying to maximize the profit. So they're looking for the absolute max. So we look at these numbers. The largest number is 318. So the absolute maximum point is 9,318. But they want to know what? Find the number of units that are produced to maximize the profit. So the number of units, which gives our maximum profit, is 318 when X is equal to 9. So they want to know the X value, how many units do we have to produce to get a maximum? So that would be X is equal to 9 to get our 318 maximum. Okay, and that's it. That's all the homework for, what section is this? 3.5. And so there's one more section, 5.3, and then we'll be done with test 3 material. And I don't think any of it is that bad, but I'm a math teacher. So here's my buddy, my document camera. So let me know what you think. Okay, get busy, get started. Let's get this done. You got a lot of stuff online. I feel like this is doable. So, okay, let me hear from you. Take suggestions. What's good, what's bad. I mean, I can't change my voice or my hair or how I talk, but, let me know. All right, be safe. Bye.